think on the test, I think y'all did better than last time on average. The neat thing about Canvas is it gives you all these statistics. The high score was 98. The low score was 33. The mean score was 75, which is average, which is perfect because that's what average should be, right? So that tells me it was, a lot more people, I think only one or two perhaps got the low score or had below passing, and that can be fixed with details. Nobody's given me any details yet, so.
What kind of details?
Just drawing details that are in the book, and like what we see, we're going to see a lot in the lecture today. If you look at it, you can copy those. You get 5 points each. So I would suggest that for those of you that need it. One thing I want to remind you of is that Monday I have a guest lecturer coming. He's a guy in the masonry industry, and he'll probably bring some good samples and just have a little bit different viewpoint than me. So that'll be exciting. If you know anybody in the online class, they're welcome to come, or anybody else. I will try to, I'm not sure what kind of presentation he'll have, but I'll try to record it for the online people if they can't be here. So then, as far as the schedule goes, I think what we'll do is today we're going to go over chapters 8 and 9. Then I still want you to read through 10 by Monday when he's here, because all those 3 chapters are on masonry and masonry construction. So, it'd be nice for you to have a little background. And then we're scheduled, it says on the calendar, for an exam on masonry, chapters 8, 9, and 10, a week from today. But what I think we'll do is, since we have the guest lecturer coming in, I don't want to take time from him, is on next Wednesday, we'll talk about any other highlights in those chapters that perhaps we missed. We'll answer questions. We'll look at, the review. I think I've already put the review online, so y'all can be answering those questions. And then the exam will be on your own time, like take home. So if we have time Wednesday, you can certainly start it here, finish it here, or you can just go home and take it. So that way we don't make sure I try to stay on track, because I don't know if y'all realize in October, the week of October 28th and 30th, all the architecture classes are canceled because Ms. Bennett has a special project for Halloween, in which everybody's supposed to participate. So we won't have our regular classes that week, so it'll be a nice little break. But instead, we're going to have a design charrette. She's going to give a special lecture, and then everybody's going to help build this or design these little projects having to do with death, I guess, versus Halloween. But like a mausoleum and gravestones and things like that. She's working out all the details, but you'll be expected to participate in that, and that will reflect in, I'm not sure how in this class, maybe just an assignment grade or something that you participated. But anyway, that's why there's really not a lot of time to get through everything, and so we got to really try to squeeze it all in. So I think that's all my updates. Any questions on that? Okay, then I'm going to.
Did you say the next exam was?
Well, it's on the calendar. It says it's going to be a week from today.
Okay.
But since we have a guest lecturer on Monday,
Yes,
Wednesday we'll review anything over these 3 chapters, 8, 9, and 10 that we need to. We'll talk about the review, and then y'all can certainly start it here if there's time, or you can take it home and do it.
okay.
It's still, it's the same thing. It's a 90-minute limit and
Yes,
stuff like that. So, okay. So right now I'm going to look through the PowerPoint of that's also posted online, and just point out the highlights, and then we'll do some masonry problems, worksheets, and get going. So I'm not really going to read through all this. I'm just going to look through it and look for high points. Of course, masonry is all different kinds of things. There's and the way you the way you construct it, you know, affects the appearance. You can see here, we talk about, if you've read the chapters, you understand that there's different patterns and different mortars, and you can see clearly here how that affects the appearance. You know, the one on the far right, this one right here, has a very linear appearance because there's no vertical joints, or the bricks are squeezed together, but you can see the strong horizontal joint. So that's all stuff that, you know, architects can control in their buildings. Now these slides, it's important for you to know the basics of mortar, and when you specify things, when you become an architect, like you all will, when you write your specifications for your masonry building, you need to know what all this means, and you need to include that information in your specifications. I mean, this is all just kind of science. It's stuff you can always look up, you know, to make sure you're doing it right. But I'm not really going to spend a lot of time telling you the formula for making mortar. Y'all need to read through it, of course, but I don't want to spend the class time on it. So let me find something that's interesting. One thing as architects that's more interesting is you can always add colors to make things appear, you know, nicer for whatever your design is. You can also, things called admixtures. If you live in a cold climate, you might need an admixture that keeps the mortar warm while you increases the temperature so it doesn't freeze before it sets, stuff like that. This is a good chart to know. I think it's in the book. You know, you have different types of mortar for different things. I like to remember that as the most. For the highest strength, the very high strength masonry, when strength is important, when there's extreme weather conditions, freezing and thawing, and it's when it's in contact with the earth. You want to use the type M. Then you just go down. S is reinforced load-bearing masonry. I mean, it shows you what it's used for there. N is non-load-bearing masonry. You can remember the non-load-bearing. O is for interior, and K is for the lowest strength. So this kind of information was on the architecture registration exam, not, you know, the percentage of all that stuff. So here's more charts talking about the different parts and how it's created. That's the strength for the different types of masonry, and you can see M is obviously the highest. So then we get into brick masonry, and you know, brick is a very green product. It's made from biodegradable materials, comes from the earth. It's not manufactured. Well, it's manufactured, but it comes from the earth. It's all natural. There's different processes to make the brick, and I think there's some film clips that y'all should watch attached to this lecture on how it's, you know, stiff mud or extruded. Extruded is like a toothpaste. You squeeze it out of the tube, and it comes, and they just chop it in brick shapes. Stiff mud is more in a mold. It's so it's a little bit, probably not quite as regular. Not quite as regular as extruded. You can also score the sides, as this picture shows, to give it that appearance. Molded bricks. This is a soft mud process, which is even more loose, I guess, not quite as, you know, and sometimes you want that look. You want that rustic type look. Talks about how they're made, firing in the kiln, and like I said, I think there's a video on that that you should look through. Brick sizes. Brick sizes are kind of like wood. Remember, wood with nominal dimensions, and you know what we call a 2x4 is not really a 2x4. So brick is kind of the same way. The nominal dimensions, the width is 4, the height is 2 3/8, and the length is 8. But in reality, the width is 3 5/8, the height is 2 1/4, and the length is 7 5/8. But when you add the mortar joint, one mortar joint high and wide, then you get a 4x8. So that's why they do it that way. So and what we're going to do later is an exercise on when you design a building, you don't want the masons to have to chop a lot of bricks. You want your building to try to come out even. So it's important to know these dimensions so that your wall is a division of 8 or something, so you have even amount of bricks. Makes it a lot easier and a lot more economical. So that's just telling you the different sizes of different types of bricks. And there's all kinds. So when you start designing your buildings, you just have to look up on the internet or in the catalogs what type you want and then figure out the sizes. You can see here you've got custom bricks for these kind of situations, for like a water table, a windowsill, making corners. There's all kinds of custom bricks that you can have to influence your design. There's classifications of brick. Anything not less than 75% solid is solid brick is not less. Is that right? Not less than 70. Means there's 75% solid. If it's less than that, it's a hollow core brick, I believe. So, and you don't need bricks to be solid because they weigh too much and it'd be too hard for the mason to pick it up. So that's why there's holes in it, because you really don't need all of that density. You also can use the holes and the spacings for rebar, and then that adds strength to your wall or for your headers and things like that. Classifications such as facing brick and building brick. Building brick is shown here. That's probably a basement somewhere. Nobody really cares what it looks like. But if you're on the outside of a building like the building we're in, you go outside, that's all smooth and nice. That would be, facing brick. Grade, SW, MW, and NW. SW, I like to remember as severe weather. NW is moderate. And NW, where we live, is no weather. It's pretty much the same. There's other classifications. There's just endless. And then, like I said, when you start writing your specification, you really need to look into what you want your building to look like, what you need from your brick, and go from there. Terminology is important to understand. A course is a row of bricks, and it shows that right here. That's one course. A bed joint is the horizontal joint between the courses. So that brick right there I'm pointing to sits on that bed joint. A head joint is the vertical joint between the bricks, right there. That's the head. So you got the course, the bed joint, and the head joint. Those are things you need to understand. A withe is one vertical stack of bricks. This is one withe, this shaded part right here. If it's a double withe like this is shown, you're going to have a collar joint between the two withes. And you might need that, for instance, in a freestanding brick wall, like in a garden or something like that. Because if you think about it, that's not very stable, just one withe of brick. You need something, and a lot of times they'll show later to increase the strength between these two withes. Every now and then they'll have a brick going horizontally, and that ties it together. And I think they show that in a little while. These are also things you need to be familiar with, because these are what affect the look of your building as architects. A row lock is where a brick is laid on its face with the end visible. So this is the row lock. A stretcher, obviously, is where they're stretched out long ways. A header is where you're looking at the brick laid flat with the end visible. You're looking at the head of the brick. A soldier, they're all straight and tall and skinny, like soldiers. A sailor shows the broader side, and I don't like that because my husband was in the Navy, and that implies that sailors are fat and soldiers are skinny. I don't know. I got a son in the Navy and a son in the Army, so I guess it's okay. So here you can see how the bonding works. Here the header or the row locks cross over both withes, and that strengthens it. And you can see how they do all that to get a solid wall. Bonds are important. You got the running bond and the common bond. Running bond is all stretchers. They're all stretched out, every one of them. The common bond has a stretcher course with a header row, usually every 5 or 6 courses. So you got all these stretcher courses, and then you got a header row. That's called the common bond. The English bond is alternating stretcher and header courses. See, header, stretcher, header, stretcher. Flemish bond is alternating stretchers and headers in each course. And all of this affects the look of your building. So those are just things you need to be familiar with and know, if you want to know what it is, you got to know where to find your information. We're going to, this is an important, what I was talking about earlier. I think we're doing an exercise on that. Let me see. Well, similar to that. Where you have to understand, and this chart is in the book, I believe. You have to understand, how brick works. So on an outside corner, you're going to always have one less joint than bricks. So you have 7 bricks and 6 joints. So, if your brick is a 4 by 8, you got 1, 2, 3, 4, 5, 6, 7. And it will be 5/8 inch less because you don't have another joint there. Unless there's a joint over there, it's hard to tell. Then on an inside corner, you have an equal amount, 6 bricks and 6 joints. And then this way, it's 6 bricks and 6 joints because that's an inside corner. And then you can see here they frame their opening in the brick sizes. So that's something you need to, whatever brick you're working with or masonry, you need to try to frame your openings so that it's even. See, they got 4 bricks here. They didn't have to chop any in half to make it for a weird size opening. And then they started their opening 1 brick from the end on each side. Laying bricks, there's a video I know about laying bricks. It's interesting. You should watch that if you haven't already. You always start with the corner leads and you stretch a string, and then that keeps it all level and flat, and then you just keep going up. Tooling the joints is very important, and that also affects the look and the wear and tear on the building. So you need to understand all of these different joints. Weathered joint, concave joint, V-joint, flush joint, raked joint, strip joint, and struck joint. Some of these work a lot better in weather than others. The concave joint and the V-joint shed the most water and are most resistant to freeze thaw. And that's because the water comes out, obviously. This one can trap some water in there, and especially that one and that one. So if you're on the outside of a building, you probably always want to use the concave or the V-joint. Spanning openings, you always have to have a header course or a header above your windows, just like you do in inside construction. So you have, it's called lintels, where if you go outside of this building, you can see there's an iron angle above the windows and the doorways, and the bricks are sitting on that. You can actually see it. In this case, they have a concrete precast lintel there. This is showing how they reinforce it sometimes with a cavity wall, and then rebar and concrete or grout. Makes a very stiff, strong wall. There's the videos I was talking about that are on the website. We're going to do these worksheets in a little bit. Let me get through this first. So chapter 9 was stone masonry. Talks about stones. Again, there's a lot of scientific information here that's kind of, to me, a little bit boring, but it's important, I guess, to understand what goes into the stone and why it is the way it is. Different rocks are harder than others, and different rocks absorb more. Some, granite is a lot denser and harder than marble. You don't want to use marble, for instance, on your kitchen countertop because it's very soft, and when you cut on it, it'll make marks and it'll stain because it'll soak in whatever you spill on it. Granite, on the other hand, repels all that and is very hard to cut. So even though they look similar, they're very different. You can use marble in your bathrooms because you're not really typically cutting or cooking in there. You're just bathing and using clean stuff. So it talks about the different groups. You can read through that. talks about how they quarry it. It's kind of interesting. I don't think I'd ever want to be a rock cutter. And how they mill it and they carve it. You know, it used to be in the olden days it was all done by hand. Thank God they have tools now.
The making.
Hmm?
The making.
Making of it? Yeah. Here it talks about how to select it. Again, you know, it depends on what you need it for, why you're using it, and then you look through the charts and figure out what kind of stone would fit your purposes, and you specify accordingly. You can also use stone for cladding. Cladding is not really, you know, you go down in some downtown buildings and they look like they're made of stone. Well, they're not really made of stone. In the olden days they might have been, but now it's just a cladding, which is, you know, a surface, a finish, like a rain screen we had on our exam. So they build some sort of grid, and then they lay stone tiles on it to give the appearance of stone. You can also, you know, have it, you know, you have your masonry wall with an inside CMU, which is the way a lot of them are done, and then instead of brick out here, you would use stone panels. And there's different, just like in brick, there's different ways to lay your stone, and so it affects the look of your building. So you got rubble, which is obviously rubbly, and random, which is this, and then coursed. You can see the courses, the horizontal lines. Ashlar is squared, kind of like this. Random, laid without continuous horizontal joints, and then coursed again over here. Then you got concrete masonry, which is CMUs. Everybody's seen those before. Talks about how they're made, cured, etc. Again, they have different. They have the nominal size 8 by 8 by 16, but you chop off 3/8 inch for your mortar joint in reality, so that, you know, each brick or each unit plus a joint is going to equal that dimension, so you can figure out your building size. Shows all the different kinds there. There's more pictures. These are very strong and economical because they're hollow, so they're used a lot for the backup walls, and then you face it with, like we showed before, stone or brick. There's different classifications, just like in brick. And you've got the same dimensioning issues. Here you got 3.5 blocks plus 3 joints. When you go to the inside corner, it's 3 and 3, 3 and 3. You want to make your openings the size of your CMUs so that you don't have to cut. Here's an example of a door and how they did that. That's the end of a CMU, or a half size. And that door is probably 36-inch door because that would fit nicely in the way it's laid out. Here you can see them laying it just like brick. You know, you lay your corners and then you put your strings on there and you go across. You can obviously fill the cavities with rebar and concrete to make it very strong and stiff. You can also run, well, I guess you can't really run your utilities unless it's a totally hollow brick. But this right here is the joint reinforcing. Sometimes is required to keep it, you know, all cohesive. Here you can see horizontal reinforcing bars. You might need this sometime for what do you call it? My mind is blank.
Like a retainer wall?
A retainer wall, but where you need shear support. That's what I'm trying to think of. Or over, like that would be the way they do it over a door. If they needed a header, they would have hollow bricks with a rebar coming in, and then they would fill that with concrete. There's a very stiff construction, lots of rebar. Here you can see the header. That's what I was talking about. Because you need something that, there's going to be forces that come down here, and you need something to divert them over to the side. There's different looks, just like in brick. You can, you know, have pretty fancy looking concrete masonry buildings, depending on what you choose. You know, that hardly looks like concrete masonry at all because of the way if you look close, you can see there's a masonry unit, but it's scored so that it kind of looks like it was all just one thing from a distance. You can grind the faces for different looks. You can have glazed block and glass block. That's all included in masonry, terracotta. And there's another video. Okay. So any questions on that before we go into the exercise? Okay. I'm going to see if I can find this, figure out how to work this system. This is assignment 6, I believe. Let me see if I can pull it up on the screen. This is slow. Okay. Everybody get one? It's also on the canvas if you lose it for some reason. There it is. That's the first page. Okay, but what I didn't give you was the introduction to this, so I'll go over that. And there's several pages, as you can see here. And what I want to do is I'm going to quickly go through the whole thing, and I'll probably do like one portion of each thing for you, and then y'all can get together in groups or work on your own and finish it out and ask me questions, okay? So, for this first one, it talks about selection of bricks and mortar for a building project. This is based on both aesthetic, like I said, and functional considerations. For the first two problems in this exercise, this is the one showing on the screen, use figures 8.5, 8.15, and 8.16 in the accompanying text to make brick and mortar selections for projects with regard to strength, weather resistance, and appearance requirements. I don't know if we're doing problem 3. 1, 2. No, we're not doing 3. So I won't read that. The following are some additional material selection guidelines. The selection of brick grade, which is shown right here, is based on resistance to weathering and especially freeze-thaw action. So you want to pay attention to that. For reasons of economy, choose the lowest acceptable grade. For selection of brick type, which is this column right here, is based on appearance considerations. There is not necessarily a correlation between type and quality or cost. Often bricks that are more non-uniform are prized for the color patterns and textures they create in the wall. Compared to more uniform brick types, they may be more costly to manufacture or more difficult to lay. And then the mortar type, which is the last column right here, requires a balancing of considerations of strength, freeze-thaw resistance, and workability, compatibility with the brick units, and cost. As a general rule, select the weakest mortar type that is suitable for the job. So you always, you don't want to the sky's not the limit in construction. You want to get the most money bang for your buck. So you want to do the least required. Okay, so let's look at figures 8.5 and 8.15. Anybody got those already? What page? 311? Okay, so 311, it talks about the grade, and so that's where we'll get that information. Uh, 8.15. Where's 8.15? Oh. Talks about the different classes in 8.15, and then for the mortar type, it's probably 8.16. No, wait. I guess it's all kind of on that page. So let's just look at that. So you're looking at Little Rock, Arkansas. The exterior load-bearing wall for a 17-story building, dormitory with highly regular and smooth appearance. So what would the brick grade be? What? I think that's probably a good choice, because there can be some pretty fierce weather in Little Rock, Arkansas. I don't know if I can write on here with the slide up there. Fine. Oh, no. I'm not that technologically advanced yet. Thought there was a way to do it, but I don't know how. Hold on. I'll just talk about it. There we go. Okay, so for your first Little Rock, Arkansas, the grade would be SW. So then what type do you think? And you can find that probably in 815, maybe? Or on the, if you look over here on brick type, the last paragraph on 310. What'd you say? I think so. That would be FBX, because they want it to be a regular, smooth appearance. And that's what it says. FBX bricks have more stringent limits on appearance, characteristics, and are intended for masonry work with very thin joints. And then finally, the mortar type. Let's see where they talk about that. Having a hard time finding that in the book. 303. Okay. Yes. Yes, you would want M because you need a high strength mortar, because the structural loads are going to be high, and it's going to be the most the strongest.
You said
What?
M?
M is in Mary. So that's the first one of that. So now you kind of know how to do that. Let's see. We'll come back to this number 2. I don't know if I want to do that one. So on the next page, of course y'all can read that, but it talks about the brick dimensions. It says if you study figure 8.22 in the text, and that's the slide I was showing you earlier with the different exterior corners, interior corners. You will see that the derivation of a building dimensions from masonry unit dimensions is not difficult, but does require some care. The basic unit of horizontal dimensioning for a brick building is the length of one brick plus the thickness of one mortar joint. So that's your basic unit. If we are using a modular brick that is 7 5/8 for the brick plus 3/8 for the mortar joint, which adds up to 8 inches. So that's the horizontal dimension. And then, but a masonry wall that stretches from one outside corner to another outside corner always has one fewer mortar joints than the bricks. So you just kind of got to remember that, or refer back to that chart.
What page was that chart on?
318. The easiest way to figure out the exact length of the wall is to multiply the number of bricks in the wall by the basic unit dimension, then subtract one mortar joint. So the example they say is 7 bricks by 8 inches is going to give you a 56-inch wall. 56 minus 3/8 inch joint is going to make the wall 55 and 5/8 inch long. 55 and 5/8 equals 4 foot 7 and 5/8. A wall that stretches from an outside corner to an inside corner, such as the one in the center of the figure 8.22, has the same number of mortar joints as it does bricks. Thus, this 6 brick long wall is simply 48 inches long because it's 6 times 8. Openings, like I said earlier, have one more mortar joint than masonry units. The opening to the right in figure 8.22 is therefore figured as 4 bricks times 8 is 32 inches. 32 plus 3/8 equals 32 and 3/8. So that goes out to 2 foot 8 and 3/8. And the reason it has one more mortar joint is because you have the even number there in the bottom, and you can see, so you have to have a mortar joint before the next brick starts. Many types of bricks, though not all, are proportioned so that 1 brick length plus a mortar joint is equal to 2 brick widths plus 2 mortar joints. Thus, modular brickwork is dimensioned in length increments of 4 inches because, like I was saying earlier, if you look on the corner on page 318, you can see some of the bricks at the corner of that outside corner, you got a half a brick, so that works out to the modular dimension. So it gives you a little bit more flexibility. Height dimensions of the masonry are figured in a similar way. Bricks are dimensioned so that 3 courses of a brick plus 3 bed joints of a mortar add up to 8 inches. This is convenient because 3 courses of such brick exactly match the height of 1 course of concrete blocks. As I mentioned earlier, a lot of times you'll have a concrete block wall and then faced with a brick wall. So then you can, they won't be weird dimensions because they are aligned with each other. For bricks and concrete masonry units that are made to dimensions other than these, different basic units of length might be computed, but for general principles are the same. So that was all that. So then you look at this page, and the small rectangular building whose plan is drawn below is to be built of modular bricks. Before construction can begin, you must work out exact dimensions to guide masons. Count squares, and you really can't see the squares, can you? I have some, the squares are 1/4 of an inch. I have a few scales here. When you get to that, we can share those. So you can count squares to determine each dimension approximately, and then fill in the exact dimension of the brickwork, accurate to the nearest 1/8 inch or 1 millimeter, in such a way that only full bricks and half bricks need be used in the stretcher courses. Check your work by adding each corresponding overall dimension. So let's look at that. Let me do, which side do you want me to help you with? The one that's just no windows in it? You want me to do that one? What? Do the right side? This one right here, or this one right here? Well, first of all, we need to, let's see. We're going to use nominal 2 1/4 inch bricks. We're, like it was saying, 3 bricks plus 3 mortar joints equals 8 inches. So the height of 1 course is going to be 8 inches, and 3 courses equals 2.68 inches. So then, that's for the height. Do we need the height? get that. Oh, I was reading the wrong one. I'm sorry. The small brick masonry dimensions as illustrated in figure 8.22 of the text and further discussed on pages 66 and 68 of the exercise book, which is what I just, the pages before this. Trying to figure out, one second. So maybe I'll do two walls with you. Let's do this one first because we need to figure that out. So can anybody see the squares? Or anybody know how to use a scale?
I have a workbook I can
Well, you can measure that and tell me how long it is.
Which wall are we doing?
It's a 1/4 inch. You're going to use a 1/4 inch scale on there.
Which one?
The top one. We're going to do the top wall first because that's easy. It's what?
20?
The outside to outside?
Yes, sir.
So it must have shrunk. Okay, so sometimes when you copy things, it shrinks. Okay.
I have 21 squares from outside to outside on my back.
You can see the squares?
Well, on my workbook I can.
Oh, you have the workbook. Because that's what it's supposed to be. It's supposed to be 21. So I think the copies shrank. So what do we do? Well, let's say it's 21. So write that on your paper. This is going to be 21. Well, the squares is 21. So the dimensions of that are going to be, because a brick is what? 8 inches? The long dimension is 8 inches, right? So when you have an outside corner like this, you're going to have, it said earlier to subtract a joint or add a joint? Subtract a joint. So you're going to have 21 feet. Let me take this off a second so I can write on here. So to figure that, I'm going to just draw this roughly. Oops. And it's going to come down like that, over like that. So even though that's a little crooked, we're saying we have 21 feet here. And then you're going to say you have, so to figure that out, you're going to go 21, sorry for my handwriting, times 12 to get your inches. So what's that equal?
2 feet.
What?
252.
252? So you got 252 inches. Now you're going to divide that by 8 to get how many bricks would be there.
31.5.
But don't we take off the 3?
Well, I'm not there yet. I just have to write so slow. So you got 31.5 bricks. Well, you can't, let's see. So 31.5, I guess that's fine. And then you're going to take off the 3/8 inches. So maybe I did an extra step there. You're right. So we can't have 31.5 bricks if we go, because the modular dimension is 4.
You got 252 divided by what?
8.
8?
I did it times 12 to get my inches, and then I wanted to see how many bricks were there, so I divided by 8 because that's the modular dimension. So, but in order to get the length of this wall, we're just gonna say, we can say 21 feet minus the 3/8. So that's gonna give us what? It's gonna give us 20 feet, 11 and 5/8, right? That's the exact dimension of that wall. So then if you want to come over here, and how many squares are on that side? On the right side?
Oh, I'm sorry.
Just so that we can all figure it out the same.
I guess in that,
12.
yes.
12?
12, yes, ma'am.
On this short side or the whole thing?
The short side.
So there's, I'm going to write that number over here. There's 12. While we're doing this, how many squares are on this side right here? She's looking in her work. She's looking in her workbook to count the squares so that we all have the same. A square is 1/4 inch. So this wall is 12 squares long. That wall is 7, and what's this one?
That one's like 5 3/4.
From outside to outside?
I'm sorry, wrong way. 5.
5? Okay.
12, okay, so 12 is the whole wall, right?
Yeah, I'm just figuring out. So
The 12 is at
From the top to the bottom.
from there to there,
yes, ma'am,
there to there.
it's 12.
This is 7 squares, which is 7/4 of an inch. This is 5, and then what's this one? The whole just length. 1, 2, 3.
From that 5 corner to the
Yes,
outside
over
wall.
to here.
14.
That's 14 squares. And then this one must be 17 over here, right? Because 12 and 5 is 17. So now, let's all work off of that.
But there's a bunch of windows in there.
Right. It does. So, there's a window. I'll just draw it roughly here. One here. Then there's a, pardon my drawing. I wish I could draw it on the thing, but I don't know how. There's a window there. So on this one, you remember I'll do this wall for you. And they want dimensions. All those crooked dimensions. So let's start at the top. And there's how many squares do they have from? It's 1, 2, 3, 4, 5, 6, 7, 8. There's 9 squares, which is 9 feet from here to here. So if that's the case, we have to subtract 1 mortar joint to get that dimension. So what would that be right there? If it's 9 feet minus 1 mortar joint up here, right, it'd be 8 feet 11 and 5/8. I don't know how I can write that.
Oh, you subtract it from the largest side? Or,
Because it's outside to outside.
alright.
8 feet 11 and 5/8. You can read my writing. Okay, then you got a window, and remember what did it say about windows? You add a mortar joint, and that window is 2 squares wide, which is 2 feet. But and 2 feet is 24 inches, so that's an even. That's a what do you call it? Divided by 8, that's even, or 4. So if you're subtracting a mortar joint from 2 feet, or you're adding a mortar joint, I'm sorry, from 2 feet, what would the window dimension be? What? 2 3/8? Yes. 2 foot 0 and 3/8. You should write them vertically. I can't do that on here. Maybe I'll try to write on the screen.
2
Wouldn't
feet.
it be one?
No, the opening is 2 squares, which is 2 feet. And for a window, to get the mortar evenly, you add a mortar joint. It said that in the reading before this.
Says 2 feet. What?
0 and 3/8. Let me see if I can write better on the screen. Not much better. Okay, so then moving down the road, you have 1 square between those 2 windows, right here, which is 12 inches. So
So 1 feet.
it's 1 foot, but 12 is also divided by 4 evenly, so that's fine. And you're going to take out a mortar joint there. So what would that be? 11 and 5/8, because you have 12 inches minus a mortar joint, which is 3/8 inch, equals 11 and 5/8. So that one's going to be 11. I'm going to write it over here.
Where'd you get the 12?
Because it's 1 square, we can see it on the paper, you just can't see it on your copy. So it's,
Oh, as an inch?
huh?
As a foot?
It's drawn at, a 1/4 inch scale, so 1 square is a 1/4 inch, which equals a foot. So that was 11 and 5/8. 11 and 5/8 inch is that one right there. Then you got another window, and you can pretty much see it's the same size as that other one, right? So you have, it's 2 feet, and you add a mortar joint for windows based on the rule. So it's 2 feet 0 and 3/8. That looks like a 2. Right. So this one right here is going to be 2 feet 0 and 3/8. That one right there. Then you got to go to the end of the wall, which is 3 squares, which would be 3 feet. And that's, you're going to, based on the rule of thumb, you're going to subtract a joint. So that would be, if it's 3 feet minus a joint,
2 feet, 11 and 5/8.
right, that'd be 2 feet 11 and 5/8.
You get 3. What?
You have to subtract a joint. So it'd be,
How long is the joint?
3/8 of an inch.
Okay.
All joints are 3/8 of an inch. Because your brick, remember that your brick, if you're looking at a side view, and a joint there, and a joint there, your joints are 3/8 inch. Your brick is 3 and 5/8. That's the tall side. And this way it's going to be 7 and 5/8 plus 1 joint of 3/8. So then you got your modular dimension of 8 by 4. That's how it works.
I got the 3. Subtract by 3/8.
Yes. When you're taking out a joint, when you're adding a joint, you add 3/8.
Yeah. And you got what? 2 what? 2 feet.
Right here?
11.
Yeah. I'm sorry that's so hard to read. You have to listen to me. 2 feet 11 5/8. So let's just go on and finish this together. It's kind of tough. So we know that this bottom one is 14 squares long. I'm going to erase that because it's in the way. But, so that means it's 14 feet. I'm going to put that down there. And we do have an opening in it right there. And this is going to be an outside to outside. So from the outside corner to the opening is 1, 2, 3, 4, 5, 6, 7 feet. So we're gonna have 7 feet minus a joint, so what's this dimension gonna be? 6'11" and 5/8", is that what you said? Then your opening is 6 feet approximately, and we always add a joint to an opening, so that would be 6 foot
and 3/8.
0 and 3/8 there. And then to the end, the corner right here, it's 1 foot, and we need to subtract a joint. So that's what?
11 and 5/8.
Okay, I'm gonna write that down here. 11 and 5/8. There's that one. Might as well keep it. I think it has your dimension line going over here to the corner. And then you got a door right there. So there's 1 square. This is 7 feet long. There's 1 square before the door. So
The door is 3 feet.
the door is 3 feet. So if you got an opening, you add a joint, right? So that's going to be what?
3 and 3/8, or 0 3/8.
3 foot 0 and 3/8. So then on this side we have 1 foot. We take out a joint. No, wait, we don't take out a joint. Look at the rule of thumb. It's just 1 course, or one unit. So that's just going to be an even amount. So that's going to be 12 inches on this inside corner. Okay. Over here, there's 3 more feet, but it's an outside corner, so we take out a joint. That's going to be this dimension right here. So if it's 3 feet long minus a joint, 2 feet 11 5/8. I think it's getting kind of crowded. Okay. Then we have the last one is actually 2 more. We got to figure out these dimensions here. So we got
There's 5 squares, so that makes sense.
right, and if you look at your figure 8.22, when you got an outside to inside corner, it's even bricks and even joints. So that's 5 feet long. So that's going to be exactly 5 feet long, right? So if you did it properly, you'd write 5 feet 0 inches right there. Then you got an outside to outside corner right here, which is 12 feet long. When it's outside to outside, we subtract a joint. So what's that going to be? 11 feet. Sorry. Okay. We did that one. Anybody have any questions?
It's wanting us to put the whole bottom going into
Well, then you just add those up. The same with that right side. So it also should be, when you add all those little dimensions up, it should add up to this, because it's a square building, right? So we can check that, although it's painful to add all that together. Huh?
I don't think it adds up,
Well, let's.
Sure.
because that one side's 5 foot plus 11 and 11 inch, 5/8. That's only
That would add up. Let me scroll down. 17 bricks long, and we know that it has to equal,
Yeah, equals.
so you're gonna have your 5 feet, 0 inches, plus, 11 feet, 11 and 5/8 equals 5/8, 11, 16 feet, 11 and 5/8, and that's 17 squares long. Oops, sorry. Okay. So that's, that right side adds up to that. So the overall dimension by that room, if you added that, if you continued that out, it would be the 16 foot, 11 and 5/8. Does that make sense? So then if you want to add this string on the bottom together to see if we get the 20 foot, 11 and 5/8, you can do that. 6 foot, 11 and 5/8 plus 6 foot 0, 3/8 plus 11 and 5/8 plus 12, or 1 foot, plus 3 foot, 0 and 3/8 plus 2 foot, 11 and 5/8. Of course, the first thing you do, what I do anyway, is I add up all my 8s. So I got 5 and 3 is 8, and 5 is 11, and 3 is 14, and 5 is not. It's going to be 19 eighths, right? I did that right? Then I'm going to add up all my inches. 11 and 11 is 22, and 11 is 33 inches. So I got 33 inches. Then I'm going to add up my feet. 6 and 6 is 12, 13, 14, 15, 16, 17, 18. So now, of course, that's not necessarily the way you want to see it. So, how many times does 8 go into 19? Twice? So that you're going to add 2 over here, so then you're going to have 35 and 3/8. But you got 35 is more than a foot, so that would be 2 feet to there, so that's going to make that 20. And then 24.
Where did you get 35 from?
Because I have 19 eighths,
Yeah.
so
Oh,
I'm converting. Okay. And then 35, there's 2 feet, 11 inches in that. So I added 2 feet to that, and I have 11 and 3/8. Is that what we have? Yes, that's right. Yay. So does that make sense? Okay. Finally, the other part of the exercise is, let's see, where did that go? Okay, so we got that. And this is just more looking in the book. The ceiling of this building will be flat and constructed of wood joist. If the ceiling height is approximately 9 foot 6 inches, so this is going to be dealing with the vertical height. If the ceiling height is approximately 9 foot 6 inches is desired, figure the number of courses and the exact height of the wall for each of the following types of masonry units. So,
page is it?
in the book,
It's a worksheet.
this is on the worksheet that I handed you. This thing.
Yeah, but I'm trying to say, is it like?
Oh, the sizes of the bricks?
Yeah.
Yes, there's a page somewhere.
Sorry.
Because they want you to do all these different types of bricks. So let's see if we can find that page.
308, I think.
308. sizes. So for the first one, which is modular brick, if you want approximately a 9'6" high ceiling, how many courses and the exact height of the wall for each of the following types of units. So if we look, a modular brick is 2¼ inches high, right?
Yeah.
So if we turn the 9'6" into inches, if you want me to work that out or just verbally do it? Yeah, that's fine.
So visual.
I just hate the way I draw
Maybe
them.
114.
Hmm?
114.
Is that what that is? Hold on, I'm gonna get my stuff together. Okay, so I'm gonna do the modular brick one for you. And you want a 9'6" ceiling. And what was it, 2¼ inches? So 9'6" times 12 is what? Which is what you say?
114.
114, which is 9 feet times 12 plus 6. So that's 114 inches. So our modular size is 2¼ inches high. And then, make sure I don't forget anything. So if one course of brick is, well, remember that the way you figure that is 3 courses of brick are going to be 8 inches. That's the modular dimension. So you're looking at 3 bricks tall. Of course, I'm not drawing this to scale. They should be longer. That's going to be 8 inches. And then, of course, if I drew them longer, that would be 8 inches too, with a joint in it. Got that? So, what's 8 divided by 3?
2.67.
2.6.
Right, so 8 divided by 3 equals 2.67 inches is going to be for each course. So now then, what's 114 divided by 2.67?
42.69.
42.69? So you could round that up then to 43. You're going to have 43 courses. Then you got to go back and say 43. But you can't have half a course, right? So you're going to say 43 times your 2.67, because that's how tall each course is, equals what? 43, I forgot. 114.81. And if you want to take that to feet, then you got to go backwards like we did up there, and it would end up being 9 feet 6 3/4 inches. And you would do that by saying 114 divided by 12 equals whatever, and then you would figure out how many inches are left over. Do you understand that? So then you're going to do the same thing for each of those other ones that they asked you about. Engineer, you're just going to look on that chart and so forth. Let's just do down through the Norman brick. Don't worry about these right here. So what I want you to complete then is, I'm going to go back up here. I want you to finish this chart. I don't want you to do this right here, not number 2. Complete number 1. We already did that. And complete this one through number E. And that took most of the time, unfortunately. But
What was that last number on the?
on the what?
I just wanted to see that.
Yeah.
Got it? y'all can work together or take it home, or only 5 minutes left?